Hello students, in our previous class we discussed about how to represent an adjacency matrix corresponding to the given digraph as well as undirected graph. In today's class we are going to draw either a directed graph or undirected graph corresponding to the given adjacency matrix. Okay, so now we are going to draw a graph corresponding to the given adjacency matrix. So in our previous class, we discussed about how to write an adjacency matrix corresponding to the given directed graph as well as undirected graphs. Okay, so write down the problems. Draw the undirected graph or directed graph represented by the given adjacency matrix Okay, so coming to the first bit, so the matrix is 0 1 0 0 1 1 0 0 and 0 1 0. So this is the given adjacency matrix. Now we have to represent directed graph as well as undirected graph. Okay, right. So now first I am going to represent the directed graph. Okay, since the given matrix is a 3 by 3 matrix, so that we are having three vertices either in a directed graph or in undirected graph. So I am representing the vertices. Since we are having three vertices, so those three vertices can be represented in any way, in any direction. I am representing in this way. So this is A, this is B, and this is C. Okay. So first I am going to represent the directed graph. Okay. So in the given matrix, if you write A, B, C along row and along column, now if you observe the matrix from A to A, we are having 0. It means there is no self loop on A. Okay. So coming to the next element, that is also a 0. It means in between A and B also we are not having an edge. Okay. From A to C we are having an element 1. It means we have to draw an edge from A to C. Okay. So that I am drawing an edge from A to C. That too, so it is traveling from A to C. So we have to mention the direction also, since the graph is a directed graph. Okay. So coming to the second row, from B to A, we are having 1. It means we have to draw an edge from B to A and we have to mention the direction. That is from B to A. Okay. From B to B, we are having 0, and also from B to C, we are having 0. It means there are no edges from those particular vertices to those vertices. So coming to the third row, from C to A, we are not having an edge because we are having 0, and from C to B, we are having 1. It means we are having an edge from C to B. It means we have to draw an edge, and particularly that travels in this direction from C to B. Okay, and from C to C also we are not having any edge, so this is the directed graph corresponding to the given adjacency matrix. Okay, so if you want to draw an undirected graph for this particular adjacency matrix, it is not possible to draw undirected graph because the given adjacency matrix is not a symmetric matrix. This is not a symmetric matrix. So we have already discussed that in an undirected graph, the corresponding adjacency matrix should be a symmetric matrix. But here the given adjacency matrix is not a symmetric matrix. So it is not possible to draw an undirected graph for this particular adjacency matrix. Okay, so I am writing here undirected graph. since the given matrix is not symmetric, so we cannot draw an undirected graph. We cannot draw an undirected graph for this particular adjacency matrix. Okay, so coming to the next example, second one. So the matrix is 0 1 0 1 1 0 1 0. Okay, so 0 1 0 1 and 1 0 1 0. Okay, right. Once again, since the given matrix is a 4 by 4 matrix, so that we are having 4 vertices in the given, so 4 vertices in the directed graph as well as in undirected graph. Okay, so here the given matrix is also a symmetric matrix. It means the first row and first column are same, second row and second column are same, third row, third column, fourth row, fourth column are also same. So that this particular adjacency matrix can be represented in both the ways. So we can draw here directed graph as well as undirected graph. So first I am going to represent a directed graph. Okay, directed graph. So since the given matrix is a 4 by 4 matrix, so that we are having 4 vertices in the directed graph, and I am representing the 4 vertices as 1 2 3 and 4 and naming the vertices as A, B, C and D. Okay, so by seeing the matrix, we have to represent the edges. So I am naming the row as A, B, C, D and also the column as A, B, C, D. Okay, so by seeing those elements, now we can draw the edges. From A to A we are having 0, it means there is no edge from A to A. From A to B we are having 1, it means we have to draw an edge from A to B. Okay, and it is traveling from A to B, so that we have to represent the direction. From A to C we are not having an edge, and from A to D we are having an edge, so that we have to draw an edge and also we have to represent the direction. So coming to the second row, from B to A also we are having an edge, so that we have to draw a parallel edge in this way. This is from B to A. From B to B we are not having, from B to C we are having, so that we have to represent from B to C in this direction. So from B to D we are not having. Coming to the third row, from C to A we are not having, from C to B we are having. It means we have to represent from C to B, okay, in this direction. From C to C we are not having, from C to D we are having, so that we have to represent an edge from C to D, that too in this direction. Coming to the last row, from D to A we are having, so it means we have to represent an edge from D to A. From D to A we are having an edge, so that too in this direction. From D to C also we are having an edge, so that we have to represent an edge from D to C, okay, that too in this direction. Okay, so this is the corresponding digraph so to the given adjacency matrix. Okay, so now coming to the undirected graph. So we can also draw an undirected graph to the given adjacency matrix, because the given matrix is a symmetric matrix, so that we can draw undirected graph also. Once again I am going to represent the vertices A, B, C and D. Okay, so A, B, C and D. Right, coming to the first row, from A to A we are not having an edge, from A to B we are having an edge. It means we have to draw an edge from A to B. Okay, from A to D also we are having an edge, so that we have to represent an edge from A to D. Here we need not to mention directions. Okay. So coming to the second row, from B to A, we are having an edge. Yes, we have already represented an edge from A to B. So this can be treated as twice because this is an edge from A to B. We can also treat this as this was an edge from B to A since there are no directions. Okay, so we need not represent another edge from B to A. Okay, right. So from B to C also we are having an edge, so that we have to represent an edge from B to C. From B to D we are not having an edge. So coming to the third row, from C to B we are having an edge. Yes, we have already represented edge from B to C. So whenever we represented an edge from B to C, that should be treated as that was also an edge from C to B in undirected graphs. Okay, so we need not to represent another edge from C to B. Okay, so and we are also having an edge from C to D, so that we have to represent an edge from C to D. Okay, so coming to the last row, we are having an edge from D to A. Yes, we have already represented an edge from D to A and also from D to C. Yes, we are having an edge from D to C. So this is the corresponding undirected graph to the given adjacency matrix. Okay, so this is undirected graph. Okay, right. In this way, we can draw directed graph as well as undirected graphs correspond to the given adjacency matrix. One more example. So third bit. So now I am giving 5 by 5 matrix. So the first row is 0 1 0 1 0 1 0 1 0 1 0 1 0 1 1 1 0 1 0 0 and 0 1 1 0 0. So this is the given adjacency matrix. Okay, we are having 5 rows and 5 columns. So this is a 5 by 5 matrix, so that we are having 5 vertices in the directed graph as well as in undirected graphs. Also, if you observe this matrix, this is a symmetric matrix, so that we can draw undirected graph also. Okay, so coming to the directed graph, first I am drawing directed graph. So first we have to represent the vertices for the directed graph. Okay, so since the given matrix is a 5 by 5 matrix, so that we are having 5 vertices, and I am naming the vertices, representing the vertices A, B, C, E and D. So this is A, this is B, this is C, this is D and this is E. Okay, so and I am naming the vertices as A, B, C, D and E. So in the matrix also we have to represent the names along column and also along row A, B, C, D and E. Okay, right. Coming to the first row, we are not having any edge from A to A. We are having an edge from A to B. It means we have to draw an edge from A to B. So we have to mention the direction. Okay, right. From A to D also we are having. So it means we have to draw an edge from A to D. So that too in this direction. Next, okay, coming to the next row. So second row we are having an edge from B to A. It means we have to represent an edge from B to A in this direction. Next, we are having an edge from B to C, so that we have to draw an edge from B to C in this direction. And also we are having an edge from B to E. B to E also we are having an edge, so that we have to represent in this direction. Okay, so after that, coming to the third row, we are having an edge from C to B. From C to B we are having an edge, so that we have to represent an edge from C to B in this direction. From C to D also we are having, so we have to represent an edge from C to D. Okay, from C to E also we are having, so that we have to represent an edge from C to E. Yes, I have represented an edge from C to E. So coming to the third row, we are having an edge from D to A. Okay, from D to A we are having an edge, so it means we have to start with D and we have to draw an edge from D to A, that too in this direction. Okay, So from D to C also we are having an edge, so that we have to draw an edge from D to C in this direction. Okay, yes. So fourth row completed. So coming to the fifth row, we are having an edge from E to B. From E to B we are having an edge, so that we have to draw an edge from E to B in this direction. Okay, from E to C also we are having an edge, so that we have to draw an edge from E to C, so in this direction. Okay, so this is the corresponding directed graph to the given edge. Now coming to the undirected graph. Undirected graph. So here also we are having 5 vertices, so that we have to represent the vertices A, B, C, D, E. So this is A, B, C, D and E, right? So once again coming to the first row, we are having an edge from A to B, so that we have to represent the edge from A to B. Okay, and also we are having an edge from A to D, so we have to represent edge from A to D. Okay, so after coming to the second row, we are having an edge from B to A, that is already we have represented. Since this is an undirected graph, so we need not to represent another edge. Okay, so from B to C also we are having an edge, so that we have to represent an edge from B to C. Okay, from B to E also we are having an edge, so that I am representing an edge from B to E. Okay, so coming to the third row, from C to B we are having an edge that was already represented in the graph. From C to D also we are having an edge, so that we have to represent an edge from C to D. From C to E also we are having an edge, so that we have to represent an edge from C to E. Okay, third row completed. So coming to the fourth row, from D to A we are having an edge. Yes, that was already represented. From D to C also we are having an edge, that was also represented. So fourth row completed. Coming to the fifth row, from E to B we are having an edge, and also from E to C we are having an edge. So this is the corresponding undirected graph to the given adjacency matrix. So in this way we can represent a directed graph or an undirected graph to the given adjacency matrix. Okay, thank you.